Hello my dear students, in my previous video we have discussed the problems on linear differential equation. In this session we have discussed the partial differential equation, that is a module 3 definition. An equation involving one or more partial derivatives of a function of two or more variables is called a partial differential equation. Here for example, this is an equation involving the one or more partial derivative. Here we have the two partial derivative with respect to x and y, that is dou x by dou x, dou by dou x and dou by dou y. These are the two partial derivatives of a function of two or more variables. Here z is a function of two or more variables, that is x and y, is called the partial differential equation. Here the difference between the ordinary differential equation and partial differential equation is, in ordinary differential equation, here z is a function of only one independent variable. Z is a function of only one independent variable. But in partial differential equation, z is a function of more than one independent variable. Here z is the dependent variable and y is the independent variable. Therefore, here an equation involving the one or more partial derivative, that is dou by dou x and dou by dou y, of a function of two or more variables. Therefore, here z is a function of two or more variable. Therefore, this is the partial differential equation. Next, the order of the PD is the order of the highest derivative, and degree of the PD is the degree of the highest order derivative after clearing the equation of fractional powers. So here what is the order of the PD? The order of the highest derivative. Here what is the order of the highest derivative? Here the highest derivative is 1. What is the order? The order is 1. What is the degree? The degree of the highest derivative. What is the degree of the highest derivative? That is 1. Therefore the order is 1, degree is 1. Next, a PD is said to be linear if it is of first degree in the dependent variable and its partial derivative. What is the linear? A PD is said to be linear if it is of first degree in the dependent variable and its partial derivative. Here for example, here z is the dependent variable. What is the degree of the z? That is first degree. Here first degree. What is the degree of the partial derivative? That is also first degree. Therefore, here the degree of the dependent variable is 1 and degree of the partial derivative is also 1. Therefore, then it is called linear. Here in equation 1, this is linear partial differential equation, because here the degree of the dependent variable z is 1. The degree of the partial derivative is also 1. Therefore, this is the linear. If each term of the PDE contain either the dependent variable or one of its partial derivative, then the PDE is said to be homogeneous. Here you observe that the first example, here the first term contain the dependent variable z and one of its partial derivative. Here in the second term also, here this second term containing dependent variable z and the partial derivative. Therefore, this is the homogeneous. In the second example, the first term containing either dependent variable z and one of its partial derivative. But in this term, here it does not contain the dependent variable z and one of its partial derivative. Therefore, this is non-homogeneous. In the third example, here for each and every term either containing the dependent variable z or one of its partial derivative. Therefore, this is the homogeneous. And this is also homogeneous because every term in the differential equation, in the partial differential equation, either containing z or one of its partial derivative. Here also, this is a partial differential equation containing either dependent variable z or one of its partial derivative. Therefore, this is the homogeneous differential equation. Here example, here what is the order of what is the order of the PDE? The order is the highest derivative. The highest derivative is 1, that is the order. What is the degree? The degree of the highest order. What is the degree of the highest order? That is 1, that is the degree. Is it homogeneous? Yes, it is homogeneous because every term containing either dependent variable z or one of its partial derivative. Therefore, this is the homogeneous. In the second example, what is the order? That is the highest derivative. What is the highest order derivative? That is 2. That is the order of the PDE. That is 2. What is the degree of the PDE? the degree of the highest order derivative. What is the degree of the highest order derivative? That is 1. That is the degree of the PDE. Is it homogeneous? No, it is not homogeneous. That is the non-homogeneous, because here this term does not contain z or one of its partial derivative. Here what is the order? The highest derivative is 2, therefore order is 2. What is the degree? The degree of the highest order. What is the degree of this highest order? That is 1. Is it homogeneous? Yes, it is homogeneous, because every term either containing z or one of its partial derivative. Therefore this is homogeneous. The fourth example, here what is the order? Highest derivative is 2, that is the order. What is the degree? The degree of the highest order. The degree is 1. Is it homogeneous? Yes, it is homogeneous, because every term containing either dependent variable z and one of its partial derivative. Here what is the order? The highest derivative, that is 3. Order is 3. What is the degree? The degree of the highest order. The degree of the highest order is 1. Degree is 1. Is it homogeneous? No, this is not homogeneous, because this term does not containing this term does not contain either dependent variable z or one of its partial derivative. This is non-homogeneous. Next, the formation of the PDE by eliminating the arbitrary constants and arbitrary functions. Given a relation of the form f of x, y, z, a, b, that is equal to 0. Here the function of x, y, z and constants a and b, that is equal to 0, where z is a function of x and y and a and b are the arbitrary constants. How to eliminate the constants a and b here? Differentiate the given relation with respect to x and y partially and eliminating the arbitrary constants a and b to form the PDE. How to eliminate the arbitrary constant? By differentiating the given function with respect to x and y partially. In case the number of arbitrary constants are more than the number of independent variable, we need to appropriate number of partial derivative of second and higher order also. Here suppose the PDE contains the arbitrary constants more than the independent variable, then we need to differentiate further. Suppose z is a function of two arbitrary functions, we have to find the partial derivatives up to the second order. Suppose z is a function of two arbitrary functions, z is a function of x, suppose example z is a function of x and y. We need to find out the second order partial derivative. Second order partial derivative. Only one arbitrary function, we need to find out only first order partial derivative. Here two arbitrary function, we need to find out the second order derivative. Here the function containing three arbitrary function, we need to find out the third order partial derivative and so on. Next note, here there is a notation for P, Q, R, S and T. Here z is a function of two independent variable x and y. What is P? Dou z by dou x. Dou z by dou x is equal to P. That is a partial differentiation of z with respect to x. It is also denoted as zx. And Q. What is Q? Dou z by dou y. Partial differentiation of z with respect to y. This can also written as zy. And R is equal to dou square z divided by dou square. Differentiation of z partially with respect to x 2 times. That is the second derivative of z. Second derivative of z with respect to x. That can be written as R. And this can be written as zxx. Z the second derivative of z with respect to x. What is s? Dou square z divided by dou x into dou y. Therefore this can be written as zxy. How to get this one? Here suppose dou z by dou y is there. Dou z by dou y. Differentiate again this with respect to x. We get dou square z divided by dou x into dou y. That is s. And t is equal to the second derivative of z with respect to y partially. Therefore dou square z divided by dou y square, that is equal to, this can be written as zyy. Next problem, form the PDE by eliminating the number of arbitrary constants in the following. Z is equal to x plus a into y plus b. Here what are the arbitrary constants? A and b. We have to eliminate a and b, then form the PDE. Solution. Write the given data z is equal to x plus a into y plus b. Call this equation 1. Differentiate the given equation partially with respect to x and y. Here what is the differentiation of z with respect to x? That is the dou z by dou x. Partial differentiation of z with respect to x, dou z by dou x. That can be written as p. P is equal to. How to differentiate this? Here differentiate this function partially with respect to x means y is constant. Y is constant. Similarly, differentiating with respect to y, x is constant. We treated x is constant. Here differentiate this one with respect to x. Here with respect to x, y plus b is a constant. Write as it is. What is the differentiation of x? 1. 1 plus what is a? That is constant 0. Only 1 into y plus b is y plus b. This is p. That is dou z by dou x. Call this equation 1. Next q. Differentiate this term, this function partially with respect to y. Here what is the differentiation of z with respect to y? Dou z by dou y. What is dou z by dou y? That is q. Q is equal to dou z by dou y, that is equal to. Here with respect to y, x plus a is the constant. X plus a is the constant, write as it is. What is the differentiation of y? Differentiation of y with respect to y is 1 plus b is the constant 0. Therefore 1 into x plus a is x plus a. Call this equation 3. Using 2 and 3 in equation 1. Therefore z is equal to, here what is x plus a? X plus a is equal to q. Therefore q. What is y plus b? Y plus b is equal to p. Therefore z is equal to pq. Is the required PDE, the partial differential equation. Here we eliminated a and b. Eliminated a and b. Next problem, 2z is equal to x squared by a square plus y squared by b square. Write the given data. 2z is equal to x squared by a square plus y squared by b square. Call this equation 1. Differentiate equation 1 partially with respect to x and y. Here 2 is the constant, right as it is. Differentiate with respect to x is dou z by dou x, that is equal to 2 into what is the dou z by dou x? That is p, small p, that is equal to. Here differentiation of x square is 2x divided by a square. Here with respect to x, y square divided by b square is constant. Y square by b square is constant. With respect to x, y is constant. Therefore y square divided by b square is constant 0. The differentiation of this term is 0. We get only this term overall. Here divide 2 on both sides. Therefore 2 get cancelled. Therefore p is equal to x by a square. P is equal to x divided by a square. And cross multiply. A square is equal to x divided by p. A square is equal to x by p. Call this equation 2. Similarly, differentiate equation 1 partially with respect to y. Therefore 2 into differentiation of z partially with respect to y is dou z by dou y, that is equal to 2 into what is dou z by dou y? That is q is equal to here with respect to y, x square divided by a square is the constant. X square by a square is a constant. In PDE, differentiate with respect to y partially means treated y as x as constant. Treated x as constant. Therefore this is constant 0. 0 plus what is the difference of y square? That is 2y. 2y divided by b square. 2y divided by b square. Or divide 2 on both sides. 2 get cancelled. Therefore q is equal to y by b square. Therefore cross multiply. B square is equal to y by q. Call this equation 3. Using 2 and 3 in equation 1 we obtain. Therefore using the equation 2 and 3 in equation 1. Therefore what is the equation 1? 2z is equal to 2z is equal to x square divided by a square. What is x square divided by a square? Here x square divided by a square is here we have a square. Therefore write x square as it is divided by what is a square? X by p. Therefore x square divided by write x square as it is divided by x by p. X divided by p. And here denominator of denominator goes to the numerator. Therefore p goes to the numerator and x in denominator. One term of x get cancelled. Therefore p into x plus here also next y square into here this is y square divided by b square. Y square divided by b square. What is b square? Y by q. Here y square divided by b square, y by q. Here this q goes to the numerator. Therefore q divided by y. Y get cancelled. Only q into y is the required PDE. Here we eliminated a and b. Third example, Perform the PDE by eliminating the arbitrary constants. Here what are the arbitrary constants here? A and B. Therefore given data, this can be written as z square is equal to 1, shifting these two terms. Therefore minus a square minus b into y square. Call this equation 1. Differentiate the equation 1 partially with respect to x and y. Here first differentiate with respect to x and keeping y as constant. Therefore differentiation of z square is 2z into chain rule. Differentiation of z with respect to x is dou z divided by dou x, that is equal to, here with respect to x this is constant 0, here with respect to x this is constant 0. Here we get only a into what is the difference of a square, x square, 2x, therefore minus 2ax minus 2ax. Here divided 2 on both sides, therefore 2 get cancelled. We have only zp is equal to minus ax, zp is equal to minus ax, or a is equal to cross multiply minus x. This goes to the minus, x goes to the denominator. Therefore here was zp divided by minus x. A is equal to minus zp divided by x. Call this equation 2. Similarly differentiate this term with respect to y. What is the difference of z square? That is 2z. 2z with z with respect to y is dou z divided by dou y, that is equal to 2z. What is dou z divided by dou y? It is q. Q is equal to, here differentiate with this term with respect to y, keeping x as constant. Therefore what is the differentiation of 1? It is constant 0. Here with respect to y, here a into x square is constant 0, minus b into what is the difference of y square? 2y. Therefore minus 2yb, minus 2yb or minus 2by. Here 2 to get cancelled, zq is equal to minus by. Therefore b is equal to cross multiply minus y, it goes to the denominator. Therefore b is equal to zq divided by y. Call this equation 3. Using 2 and 3 in equation 1. Therefore z square is equal to 1. Here minus a is what? A is minus zp divided by x. One term of x get cancelled. Only we get azp. Az or zp divided by x. Divided by x square, plus here b is equal to minus zq divided by y. Minus of minus is plus, zq divided by y, b into y square, right as it is. Therefore thus simplify this. Therefore z square, this will become minus 1. It is equal to, in these two terms z is the constant, take it outside. One term of x cancel, p into x, plus here one term of y cancel, z is common, only q into y is the required PDE. Thank you.